Let's look at the part 3 there. Given that instead the line L does not intersect P3, what can be said about the value of mu and lambda and mu? Okay, that is pretty interesting. So now, part 3. If they do not intersect, there's only one way that it could be, right? Meaning to say, if P3 and line L doesn't intersect, means the line has to be parallel to the plane. Because if it's not they are not parallel to each other, you intersect at a point, right? So in other words, you're looking at here, this point here. So I'm going to just draw this equation like that, okay? So this one, just draw it down, looking at this point L, and this is plane 3, okay? Now you realize that the equation is the same, so I'm going to put P3 as R dot 5 lambda 17. 5 lambda 17 equals to mu. And this point here is actually -1, -1, 0. And this lambda here is actually just 1, 1, 1. Okay? Now, means if line doesn't intersect plane, okay, line L, so this will imply that line is parallel to plane. Okay, that is what we should be able to deduce. In other words, this one will tell you that actually the n dot d is still equals to 0, which if you use follow this reasoning here, so this will imply that lambda is equals to -22. Okay, but -1, -1 is not on P3. So -1, -1 doesn't satisfy P3. Okay, this is what we can write. So in other words, mu cannot be equal to 17. That is very, very important. This is what we can deduce. Essentially, mu equals to 17 would make the line on the plane, right? Because previously, when this point is on plane 3, you have mu equals to 17. So any value which doesn't give mu equals to 17 would not be on the plane. So essentially, you want the line not to be on the plane. Okay, so for part 3, that's how you reason it. Okay, so that's how we understand this part here. Okay, it's a bit confusing, I know. It's a bit out of the norm, but try and understand it from an equation perspective. You satisfy or you don't satisfy, it works as well.